Spain sits at the hinge of the world. To the north, the Pyrenees. To the south, 14 kilometers of water and then Africa. To the east, the Mediterranean. To the west, the Atlantic. For 15,000 years, every civilization that expanded far enough eventually reached Iberia. And every one of them left something behind in the genome. The story that modern genetics tells about Spanish DNA begins, as most human stories do, at the end of the last ice age. 17,000 years ago, hunter-gatherers in the Iberian Peninsula were producing some of the most sophisticated cave art ever created. At Altamira, at El Castillo, at Nerja, they painted with remarkable skill and left behind skeletal remains that researchers have now sequenced with high confidence. Those ancient individuals, the people who made the art, carry a genetic profile recognizable in one modern population more than any other: the Basque. The Basque people of northern Spain and southwestern France are the most studied genetic anomaly in Western Europe. Their language, Euskara, has no confirmed relatives. Their genome shows elevated hunter-gatherer ancestry combined with almost no steppe input, a combination that appears nowhere else in Western Europe at comparable levels. The steppe expansion, which reshaped the genetics of Britain, Scandinavia, Germany, and most of continental Europe between 4,500 and 2,500 years ago, reached Iberia late and partially. The people already there partially absorbed it, rather than being absorbed by it. The Basque represent what survived when the wave broke. To understand how unusual that survival is, you need to understand what the steppe expansion actually did everywhere else. Around 2,500 BCE, pastoralists from the Pontic Caspian grasslands north of the Black Sea began moving westward and westward, with a speed that still surprises researchers who study it. These were the Yamnaya, cattle herders and wagon builders, carrying a package of innovations that gave them an extraordinary demographic advantage. Within a few centuries, their genetic signature reached 50%, 60%, 70% of the population in Britain, in Germany, in Scandinavia. In some regions, the male lineages that had existed for thousands of years were almost entirely replaced within the span of a few generations. The scale of that replacement is one of the most dramatic demographic events in all of European prehistory. When the same expansion reached Iberia, something different happened. It arrived later, around 2000 BCE. It arrived with less force. And in the northwest, in the mountains and valleys where the Basque had lived since before farming existed, it barely registered at all. The pre-existing population did not disappear. It held. But the Basque are one thread in a much larger fabric. Ancient DNA from Iberian Neolithic tombs, from Bronze Age burials, from Iron Age sites reveals a peninsula that was never genetically static. The Phoenicians added Levantine ancestry along the coast. The Romans distributed genetic material from across their empire. The Visigoths left a faint northern European signature. Each arrival layered onto what came before. The Phoenician contribution deserves more attention than it typically receives. Beginning around 900 BCE, traders from the Levant, from cities like Tyre and Sidon, in what is now Lebanon, established ports and colonies along the southern and eastern coasts of Iberia. Gadir, which would become the modern city of Cadiz, was among the earliest. These were not brief visits. The Phoenicians maintained sustained settlements, intermarried with local populations, and left a Near Eastern genetic signal that genomic studies can still detect today in populations living near the Mediterranean coast. The Carthaginians, themselves descended from Phoenician settlers in North Africa, extended that presence further. By the time Rome arrived, the southern Iberian coast had already been absorbing Levantine ancestry for centuries. Rome then added its own complexity. 7 centuries of Roman governance meant sustained contact with every corner of the empire, with North Africa, with Greece, with the Balkans, with the Levant. Roman Iberia was not an ethnically homogeneous province. It was a destination, a crossroads, and a military posting for soldiers drawn from across the known world. The genetic traces of that diversity are subtle but measurable in ancient Roman period Iberian genomes that researchers have sequenced in recent years. When Rome fell, the Visigoths arrived. Their kingdom lasted over 2 centuries, and their genetic contribution, though modest compared to what came before and after, is visible as a faint North European signal in post-Roman Iberian remains. They were not the last wave. They were not even the most consequential one. Then came Al-Andalus. 8 centuries of Islamic governance beginning in 711 CE introduced North African and broader Middle Eastern ancestry into the southern peninsula at a scale and duration unmatched anywhere else in Western Europe. Genomic studies consistently find this component concentrated in Andalusia, diminishing as you move north, a geographic gradient that maps almost precisely onto the historical geography of Islamic Spain. The Reconquista was a political and military process. Genetics shows it was only partially a demographic one. The numbers make the point plainly. Studies analyzing modern Spanish genomes have found North African ancestry components ranging from a few percent in the north to substantially higher levels in Andalusia and the southern coastal regions. This is not noise in the data. It is the demographic echo of 8 centuries, a period longer than the entire history of the United States, during which the southern peninsula was integrated into a civilization that stretched from the Atlantic coast of Morocco to the borders of Persia. People moved, they settled, they built families, and the genome recorded it. Then came 1492. The completion of the Reconquista in January of that year was followed within months by the expulsion of the Sephardic Jewish population. Estimates of the number expelled range widely, but most historians place it between 100,000 and 200,000 people. These communities carried ancestry with roots traceable to ancient Levantine populations, a distinct genetic lineage that had been present on the Iberian Peninsula for over 1,000 years. Their departure did not erase that lineage from history. It scattered it, preserving it in the descendants of those communities now living in North Africa, in Turkey, in the Balkans, and in the Americas. A genetic thread pulled out of one place and woven into many others simultaneously. Beneath all of these historical layers sits a structural puzzle that researchers are still working to resolve. On the Y chromosome, Spanish men carry a lineage called haplogroup R1B at some of the highest frequencies in Europe. In the Basque country, it reaches above 80%, a figure comparable only to Ireland and Wales along the Atlantic fringe. For decades, this marker was assumed to have arrived with the Yamnaya steppe expansion. But the Basque data complicates that assumption directly. The Basque carry almost no steppe ancestry anywhere else in their genome. A population cannot simultaneously have almost no steppe DNA and derive its dominant Y chromosome lineage from a steppe migration. The math does not work. The leading alternative hypothesis proposes an earlier migration along the Atlantic coast, a pre-steppe movement of R1B carriers whose timing and origin remain genuinely unresolved. It is one of the most actively debated questions in the field. The result is a modern Spanish genome with no clean Western European parallel. Layers of Paleolithic, Neolithic, Bronze Age, Phoenician, Roman, Germanic, North African, and Middle Eastern ancestry sit on top of each other, differently proportioned across different regions, differently preserved in different communities. When you look at Spain genetically, you are not looking at a European population with regional variation. You are looking at the genetic record of every civilization that ever found its way to the western edge of the world. The research is unfinished. Ancient DNA studies of Iberia are accelerating, but the Islamic period in particular remains dramatically undersampled. Thousands of ancient Iberian individuals have not been sequenced. the complete genetic profile of medieval Andalusia, one of the most cosmopolitan civilizations in European history, is still largely invisible to science. Researchers expect the picture to grow substantially more complex as that data arrives. But the outline is already clear enough to draw a conclusion. Spain's genetic history is not a footnote to European prehistory. It is a separate document entirely, written in a different hand, revised by a different set of civilizations, at a crossroads where 3 continents almost touch, and where the traffic for 15,000 years never really stopped.